Alright, what we're going to look at is finding derivatives of our trig functions. And the nice thing about this is, at least for right now, the amount of memorizing that has to be done is really minimal. Okay?
You need the word. Because
Yeah.
I have.
That's fine if there's other stuff there. Just... for right now, basically all you're going to need to memorize is the derivative of sine and cosine.
Thank you.
Okay? The derivatives of sine and cosine. If you know those,
You can do everything else.
exactly, we can do everything else.
You can. Is that everything?
So let's go ahead and learn the two things that we've got to memorize, and then we'll apply it and look at some other things as well. So first of all, if y equals sine of x, then the derivative is cosine of x. Okay, so the derivative of sine is cosine.
That makes sense.
Okay. Secondly, the derivative of cosine is negative sine. Okay.
That makes sense.
Now, that's all we've got to memorize. That's the easy part. Okay. So, like logarithms and exponentials, the challenge is not in the formulas themselves, just memorizing. Rather, the challenge is in applying those rules along with the chain rule, the product rule, the quotient rule. Okay? That's where the challenge comes when we're doing these. Okay?
Wait, so it's negative sign?
Negative sign, yes. We have to put a little space in there. Oh. Of course. There we go. Okay, yeah, negative sign. So, since the challenge is really applying this to other contexts, that's what I want to spend the majority of our time on here. Okay? So let's take a look first of all at this one. Let's say we've got the y equal to the sine of x squared minus 3x plus 5. Okay? What rule are we going to need to use in this one?
Chain?
Product? Chain. Okay? Chain, because this is actually inside the sign, right? Okay? And guys, that's really easy to do. Okay, is to think product. Alright, because we see parentheses. But you've got to remember, these are trig functions. So when you see something in the parentheses, you're seeing a function inside this function sign. Okay? So let's think about the derivative of the outer function. The outer function here is sine, right?
So we use chain rule for that?
So yes, we're using the chain rule.
So it's cosine times, isn't it?
Alright, good. It's cosine. Now what are we taking the cosine of?
Square x squared.
Yeah, the x squared minus 3x plus 5. When you do the derivative of the outer, remember that inner function stays the same, but then you're going to multiply by the derivative of the inner function.
2x minus 3.
Exactly, 2x minus 3. Now, what you may want to do to avoid any kind of confusion as far as, hey, what part of this is in the cosine, what part of it is multiplied by the cosine, is you may want to put this derivative of the inner function out in front. So 2x minus 3 times the cosine of x squared minus 3x plus 5. Alright? Any questions so far? Alright. How about this one? Y equals sine times cosine.
Is it our answer?
What?
This is our answer.
This would be our final answer, yes. This is our final answer. That's the derivative. Okay?
You'd have to use the product rule.
Yeah. Now on this one, we will need to use the product rule. Okay, so let's run through. If that's u and that's v,
Should we use the product root individually too? Because there's x.
well, is it sine times x? No, it's sine of
Oh,
x,
I mean
right?
general, sorry.
Okay. Technically you would, yes. What's the derivative of x? 1. Okay?
Oh, so it's just one.
So it would just be. No, that's alright. These are the things we do have to work out in our heads to make sure that we're using the chain rule. And here's the thing. If you did use the chain rule, okay, then you would have seen, oh yeah, well it's times 1, so it just is that. So that's okay. Alright, better safe than sorry. Alright, so here we have sine of x for u. So u prime is
Cosine of x.
cosine of x. And here we have cosine of x for v, so the derivative is,
Negative sine of x.
yeah, there we go, negative sine of x. Okay? So now, we've got our product rule. dy dx is u prime v plus uv prime.
Which is cosine squared of x minus sine squared of x.
Yep, u prime is cosine times cosine, cosine squared x, plus we have a sine times a minus sine, so that would be a minus sine squared x. Alright? And at this point, it's kind of a question of how far do you want to go with this? How far do you want to simplify? Because does anyone remember what cosine squared minus sine squared x?
Isn't it 1 from that number?
That's sine squared plus cosine squared. This is actually cosine of 2x. Do you remember your double angle formula? If you remember it, nice thing is it is in your formula booklet for IB. So that does work. Another thing you could have done, using that sine squared plus cosine squared equals 1, you could have plugged in a 1 minus sine squared for cosine squared, or plug in a 1 minus cosine squared for the sine squared. You actually could have had a couple of different possibilities. It would have been 2 cosine squared x minus 1, or 1 minus 2 sine squared x. And if you remember, all three of these were the variations of the double angle formula for cosine. Okay? However, if you stopped right here, I would be satisfied with that. Okay? So, my guess is if they wanted you to go to here, they would probably say, like on the IB exam, show that dy dx equals cosine of 2x. Alright? And that's where, definitely start with your product rule, but then that's where, going back to your IB, your formula booklet, Alright, well what was cosine of 2x? Was there some, I remember there was an identity for that, what is it? And that's where you'd be able to see it, okay? Alright, so, it's an interesting one. Let's do another one here. Y equals sine of x divided by cosine of x. Alright, so here's u and here's v. What rule are we using? The quotient rule. Alright, so u prime is cosine x. V prime is minus sine x. Good. Okay. And now we plug it into the quotient rule. dy dx is u prime v minus u v prime over v squared. So here we go. U prime times v is again a cosine squared. Minus uv prime was a negative sine squared, right? And that's all over v squared, so that's cosine squared x. What's cosine squared minus a negative sine squared?
Cosine squared plus sine squared.
Yes.
Just 1.
Which is 1. And what's 1 over cosine squared?
Secant squared.
Secant squared. Alright? So you see how our trig, you remember back when we were doing all those trig proofs and all that stuff, and it was like, why do we have to learn all these proofs and identities and stuff? Well, this is partly why. Yes?
Are we doing reviews for the exam?
Yeah.
How long?
I'm hoping for a good 4 weeks. So. Now, let me ask you something. What did we just find the derivative of? Tangent.
Oh,
What's sine over cosine? It's tangent. Okay? We just found if y equals tangent of x, then the derivative is secant squared of x.
Or 1 plus tangent squared.
Or 1 plus tangent squared, yeah, if you want to do that. Okay. If you look at any kind of list of identities or whatnot, or a list of derivatives, the general rule is tangent. The derivative of tangent is secant squared. Okay? Alright, so that's pretty cool. We can derive other ones from what we know is sine and cosine. Okay? So let's do the other 3. Okay? Now, how you choose to do these is kind of up to you, alright? But, let's think about cosecant. Cosecant can be rewritten as what? 1 over sine. Okay? Do I have to use the quotient rule?
no, because the derivative of 1 is 0.
Yeah. So how could I rewrite this actually?
Sine to the negative x.
Sine.
To the negative 10
Yeah, sine to the negative 1 of x. Okay? That would be easier than, it's always easier to use the chain rule than it is to use the quotient rule. Okay? So if you have 1 over something, change it to a negative exponent. Alright? So, and with that being said, how would I write secant?
1 over cosine.
1 over cosine, which is cosine to the negative 1. Okay? And then how about cotangent?
1 over tangent.
Yep.
Tangent.
Or cosine over sine.
Yeah, this is one where you have some options. We could either do it as y equals tangent to the negative 1 and use the chain rule, or you could write it as cosine of x over sine of x and use the product rule. It's really up to you. Okay? So take a few minutes here. I want you to see if you can derive our other 3 trig function rules. Okay? What would dy dx be for our other 3 trig functions? And try to simplify it as much as you can.
Why do you have
These
to,
aren't finished, but
yeah, but why do you have to multiply by cosine x?
Because it's a chain rule.
the inner function here is sine, right? The outer function is something to the negative 1. The inner function is cosine, or is sine.
So does that take the derivatives of the functions?
The cosecant,
Yeah.
the secant, and the cotangent. Remember, these are called the reciprocal functions. It's alright, it's been a while. Alright, so you see here with sine to the -1 or cosecant, we have -1 times sine to the -2 of x times the derivative of sine, so times that cosine. When I simplify that, I get a negative cosine over sine squared. The -2, put the sine squared in the denominator. Okay? Then I recognize that that could be seen as 1 over sine times cosine over sine. Right? I split that up. With multiplication. Okay, so that's a negative 1 over sine times a cosine over sine. Okay? So that's how we got a negative cosecant x times cotangent x. Okay? So now we have this one, a negative and a negative, so now that's positive sine of x over cosine squared x. What is that going to give me?
Tangent of x times secant of x.
Yeah, tangent times secant. Okay? And then we had this one here where you could have written this one a couple of different ways. Alright, but either way you do it, we're going to have a negative secant squared x over tangent squared x. Okay? Now the simplifying on this one isn't quite as obvious, alright? What I would do is I'd change everything to sines and cosines. So secant's 1 over cosine, right?
Yep.
So that's a negative 1 over cosine squared divided by sine squared over cosine squared. If I flip this and multiply, my cosine squareds are going to cancel out, right?
Yep.
And I'm going to have a negative 1 over sine squared, which is a negative cosecant squared of x. Now again, you could have gotten that same answer had you done the quotient rule. Okay? In fact, in this case, the quotient rule might have been faster. Because you would have ended up with a cosine squared plus sine squared in the numerator. When you did your u prime v plus uv prime, actually you would have done a sine squared plus a cosine squared in the numerator, which would have been 1 over secant squared. Okay? Or a negative 1 over secant squared. Over sine squared. And then that would have given you a negative cosecant squared. But either way, the nice thing again with these is that you really only have to have memorized the sine and cosine. Now, a couple of patterns to look at. Anything that starts with co, the derivative's negative. Cosine was negative sine, right? Cosecant's negative cosecant cotangent. cotangent is negative cosecant squared. Alright, so that's one thing that can help you make these a little easier to remember. Anything that starts with co, the derivative is negative. Okay? And there are similarities with the reciprocals. Okay? So to kind of summarize everything here, let's write all of these out. Okay? Sine of x, the derivative with respect to x of sine of x is cosine of x. The derivative with respect to x of cosine of x is a negative sine of x. The derivative with respect to x of tangent of x is secant squared.
Didn't we just say it was cosecant squared?
Cotangent is cosecant squared.
I know, but what? Go back.
Cotangent gives us cosecant.
Gotcha.
Whoops. Yeah, those are easy to mix up. The derivative with respect to x of cotangent is a negative cosecant squared of x. The derivative with respect to x of cosecant x is a negative cosecant x times the cotangent x, and the derivative with respect to x of secant of x is a positive secant x times tangent x. Okay? And again, there are a number of things here that can kind of help us remember them, even though you only have to memorize sine and cosine. You know, the notice secant is always with tangent. Okay? And cosecant is always with cotangent. Alright? Also, like I said before, all the cos, cosine, cosecant, cotangent, all of those end up being negative when you take the derivative. Okay? So, basically that's it. As far as finding derivatives of trig functions, that's really all there is to it. Then it's just a matter of, like we said at the very beginning, applying these with your product rule, your quotient rule, and your chain rule. Okay?